I'm going to review with you guys today the parallel perpendicular lines. We'll start with that. And then I'm just going to finish up those notes. So I am on 5-6, but I'm on the blank page at the end of that lesson. So that was the last thing we did together, and then there's this. So the first thing I want to review with you is how to write an equation in slope-intercept form. Remember, slope-intercept is one of the forms where you can see the slope, like these ones here. So I can see the slope if it's in slope-intercept and if it's in point-slope. I can't just see the slope if it's in standard form. So I have to do one of two things. I have to either isolate y, usually that's the safest bet, you're least likely to drop negatives, or use that quick route of taking negative a over b. And remember, a and b are just the numbers that are the coefficients of x and y. So if I'm looking at this one right here, I need to make it parallel, so I'm going to use the same slope. I'm going to use that 3 as is. I don't have to go to any trouble. I find my slope right away. Good to go. And they give me this point right here that it needs to go through. That point isn't another y-intercept. It would be super cool if it was, because then I could just put this and this together and be done. They gave me a point that's out space, so I can't plug it in right directly to this equation. So I use this equation. And I plug in my 3, my 1, and my 3. So I have y minus 3 equals 3 times x minus 1. I'm going to turn this now point slope that was just convenient because of what I was given into the slope intercept I've been asked to use. And I get y equals 3x. So remember, the point that they give you, if it's not a 0, 5, 0, 2, something like that, you're probably going to want to start with point slope to get it to the slope-intercept equation. And if you feel like you want to check your answer, you can. You can use Desmos. You can also use the calculator. It works best on the calculator if it's in slope-intercept, Desmos if it's in standard form. So you just want to type it in. And I have 3x plus 2 and 3x. So I hit second table. That lets me know if it's going through the point 1, 3. So my red line, my new one, goes through 1, 3. And then if I hit graph, I can tell if they're actually looking parallel. And they are. So it looks like I probably did it right. Now, perpendicular, that is the one where you take the slope that you're given and you have to use what's called its opposite reciprocal. The opposite reciprocal is like if I had a slope of 5, its opposite reciprocal would be negative, and then 1 over 5. Opposite reciprocal for perpendicular. This equation doesn't show me the slope. So I'm going to do the safest bet, and I'm going to isolate y. So I will subtract 1x from both sides. Now I'm going to take this slope, positive 1/2, and turn it to its perpendicular. Flip it and change the sign. So this is the new perpendicular slope. I'm going to use that slope in this point to create my new line. Now if I was going to use that quick method, I would say I need to use negative a over b. So 1, negative 1 over negative 2. The slope is 1 over 2. Then I would turn that perpendicular by saying I have the opposite reciprocal. So if you feel like it, instead of showing this work, you can do this work. Sometimes people feel uncomfortable with the negatives, feel like they're going to mess it up. So then this is, you can check your steps as you go. So I have identified the slope, where in the last problem I could just be like, oh, there it is. You know, now I had to putz around to find it. Now I'm going to use my point and this slope to create that new line. what in the calculator was like my red line. So I've got y minus negative 6 equals negative 2 times x minus 1. I'm using this form, not the one they requested, because I have a point, not a y-intercept. It's just a point out on the grid, but it's not sitting on that y-axis. So I've got y plus 6 equals negative 2x plus 2. And here's my equation that I would assume is perpendicular to this one. Now this one is in standard form, so if I wanted to use my calculator, I'd have to use that form of it to be able to check it. Or I could type it into Desmos and check it that way. So if I type in oops, 1/2 x minus 2. Now remember, this calculator will do fractions. It's right here. You hit the green key and then y equals. Your fraction options do show up. It was a one that was easy to convert to a decimal. Then I'm going to put negative 2x minus 4. And I need to make sure it goes through the point, the line, the second line goes through the point 1, negative 6. And that's right there. And then hit the graph and just kind of make sure that I can see that they look fairly perpendicular. If you're looking and you're like, well, that definitely does not look perpendicular. Part of it is because if you look at the scale of the y-axis, I had to tweak that. So if I were to change that window and make this closer to 10 instead of 15, it might look more perpendicular. Every time you mess with the window, it does that, where it doesn't look quite perfect anymore. And this isn't a perfect square anyway, it's a rectangle. So the spacing between these and these isn't the same. That's going to make that look less perpendicular every time you're working with it. Just so you know. And sometimes on Desmos you can control that better, so that's why some people would prefer to use it. All right, now, the next part, the part you're going to see in your homework today, is you're just going to be given two equations, and you need to tell if they're parallel, perpendicular, or neither. It's pretty easy. I think you're just going to have to put it into one of the two forms where you can actually identify the slope, or show the slope. So we wrote this yesterday. I can see the slope in these two. In this one, I'm going to have to either isolate y or use this to determine the slope. So when I look here, I can see the slope is negative 2. Here, I'm going to say negative 2 over 1 equals negative 2. They're the same, so I'll say parallel. And both are m equals negative 2. It doesn't say to explain here, but I'm pretty sure in the homework it does. Right here, I've got point slope. So there's my slope, plain as day. I'm going to use negative a over b. So negative 2 over 6 equals negative 1/3. Opposite reciprocal, so they are perpendicular. One is 3, the other is negative 1/3. This one, slope is 4. If I did negative a over b, I'd have negative 1 over 4. So that's 1/4. This one right here, these are neither. Those ones can sometimes be hard to spot. Also, if you're working with double negatives, you sometimes might question whether you're doing it right. So remember, you can always isolate y and then really play it safe because you feel like you can see all the steps to it. But these two are reciprocals, but not opposite. That's why they are neither. These two can get tricky because you look and you feel like you don't have enough information, but you actually do. If you remember from a couple days ago, I think we did that on our graph paper. If you remember Hoy-Bucks. So a line that is a y equals equation has a slope of 0. A line that has an x equals equation has a slope that is undefined. And we know that Hoy makes a horizontal, Bucks makes a vertical, so those two would indeed be perpendicular if you were to put them in. And it honestly doesn't matter if it's a 5 or 2. I mean, it could be a fraction, like 1/2. It still wouldn't matter, because this line is going to go this way, this line is going to go that way. Whoops. And they are perpendicular. And the reason is, one is horizontal, and the other is vertical. All right, that's that. You guys are going to do your homework today. I think I changed it from the original just because I know I wouldn't be here to be able to answer a lot of your questions. I feel like the ones I assigned are ones that are pretty reasonable for you to be able to get done on your own. And then just make sure you check Google Classroom so you're doing all of the parts. I'm going to throw in an IXL lesson quiz. So there will be today's homework and the IXL lesson quiz. And you can do those in any order.